Wait.
So when we do proof by induction, there are 3 steps, right? Three main steps. The first step is when n equals 1. Okay? So you just substitute that number, side equals. What about the right hand side? So the left hand side equals the right hand side. No, we've only proved one case. Remember, we need to prove all the cases. So this is the first step. First step. When n equals 1. So you always start with when n equals 1. Okay? Because if it doesn't work, you know, proof done, you finished. It doesn't, you proved it doesn't work. Now this is where it can get a little bit complicated. So we assume n, oh wait, I should have said let. Yeah, so this is step 2. N equals k. So let n equal k. We assume n equals k is true. Now k is just an arbitrary number that's equal.
And then just go n plus 4.
Because n represents the final number, where k represents a number we're substituting in for n.
Oh.
Does that make sense?
Yeah.
It's a bit weird. Okay, so now the third step, n equals k plus 1. So we've got 1, let n equal k plus 1. So to do this, we take the second step and we just add to both the left-hand side and the right-hand side k plus 1. Because the next thing in the sequence is k plus 1. Does that make sense?
What? K plus 1.
Oh, yeah.
Don't you need brackets?
So I'm going to add k plus 1 on both sides. Because if it's, you know, 1, 2, 3, 4, 5, 6, and then the next one will be 7. Okay.
Wait, why do you have both k? Shouldn't it be 1 plus 2 plus 3 plus k plus
Very end. The thing.
squared plus k over 2 plus k plus 1.
So this is the sum, or this is the equation for the sum, right? For k. So instead of k, now I've got k plus 1. So what would it look like?
It's kn on 2.
K plus 1, k plus 1 plus 1 over 2. So where the k is, I've just substituted in a k plus 1. So that's the final answer I'm trying to get to.
Oh, wait, how do you stop it? So we do say that would be equal to that. That can't be.
That's what we're eventually.
So you subbed k plus 1 in there. That was just another way of writing it.
Wouldn't it have to be what?
Is there any reason it's a square bracket?
Yeah.
Just so you don't get confused.
Just, yeah.
How do you get to that?
So how am I going to get to that? Any ideas? Look at the difference between that one and that one. There's one real big difference.
There's a k plus 1 instead of a k.
Or you put them over.
They're all over 2. So let's put this one over 2. What does it become? Another way is factorizing. So let's go back again.
Okay, that makes more sense.
What's the common factor in both?
K.
No. There's a multiply here. Both this term and this term both have k plus 1. So what's left over in this term?
Plus k plus 1.
And what's left over in this one?
K plus 1. Oh,
K plus 1 divided by k plus 1 is 1.
k plus 1 plus 1.
So now we want it all to be over 2. So this is going to be over 2. K plus 1 bracket k plus 2 over 2. Yep. So there's the factorized way, or there's, what did I do? The common denominator way.
Yeah, no, I much prefer that.
You like the common denominator?
Can you leave it as...
So I'll do the common denominator one. K dot k plus 1 plus 2k plus 2
Yeah.
over 2. Now we want to get it to look like that. So,
That's so much easier.
yep, so then we could multiply that. K squared plus 3k plus 2 over 2, which then factorizes to that.
That's so much
So 2 different ways. Your brain will work in different ways. I will give marks to both ways. Yep, big last statement. A is true for this statement. N equals k plus 1 is true, then n equals k is true. We start with let n equal 1. So we will do the left-hand side. It's just 2 to the power of 1. So the left-hand side equals 2.
And you don't have to show any like left-hand side, right-hand side for step 2 when you sub in k.
No, because you're just assuming.
Okay.
All right, right-hand side is just 2 squared minus 2, which is 2. Left-hand side equals right-hand side. Therefore, true for n equals 1. Okay, so that's the working out for step 1. Minus 2. Okay?
Wait, one.
So that's step 2. Alright? So those 2 steps should be really easy marks for you on a complex question on the exam. Okay, so let's n equal k plus 1. So we're just doing k. So we're just doing the k bit, and then we're going to add the next bit in the sequence. Does that make sense?
Yeah.
And we just add that to both sides. So we've just taken that down, and we're going to add the next bit of the sequence. Okay? Any questions?
Do you just group
Right, now we're going to group it together.
and then write?
So we've got 2 times 2k plus 1 minus 2. Does it make sense?
I see what you've done there. I don't
Those 2 added together, it's 2 of those.
So it's 4k plus 1
Oh,
minus
you could do also 2 times.
Which is
2k plus
when
1.
you multiply the same bases, you're just adding the integers. So it's k plus 1 minus 2.
what the heck?
Oh, okay.
So I'll just do it again slowly. K plus
Wait, I should do it the other way, like-
k plus 1 plus 2k plus 1 minus 2. See how there's 2 of those? This is just the way I did it. You could have done it
And you have to
differently.
leave it in plus 1 plus 1.
So it's 2 times 2k plus 1. Does that make sense?
Yeah, but how do you get the plus 1 plus 1?
Yeah, the same base.
Same base. So this is just integer laws. 2 times 2, you add the integers. So it's like 1 plus k plus 1. I'm just adding those integers together.
The 2 times 2 is 4. Why doesn't it change to 4?
If n equals k plus 1 is true for n, oh, I forgot to write this last time, n greater than, so you've got to say the conditions. I forgot that bit last time because there were specific conditions.